So today's video is on lesson 6.1b. It's the second half of the first lesson of sample spaces and probability. And this lesson is kind of split into two parts. On the front page, you have geometric probability, and on the back page, you have experimental probability. And I'm going to warn you, page 1 is a challenge. It's a challenge. So what we want to do is we're going to write down some of the most common formulas that we use in geometry, especially in our notes. So let's write down the area of a circle. I did check your formula sheet. So your official end of course formula sheet does not have the area of a circle on it. So you do need to have this formula memorized. So it is pi r squared. And then, area of a rectangle or a square. That would be length times the width, or you could just do side squared if it's a square. And then another one that's going to be useful is the Pythagorean theorem, which is a squared plus b squared equals c squared. That is an ACT favorite, let me tell you. So 90-degree triangles, let's do a little bitty 90-degree triangle. Right triangle, so that would be A and B. So A and B would be the legs, and then C is your hypotenuse, okay? And don't worry, I'm going to walk you through everything. So in probability, sometimes we have to figure out the probability of things that are geometric. So the area, if you notice, you've got a target here. And what we're going to do in this particular problem is we're going to compare the probabilities of getting 10 points to the probability of getting 0 points. So what I need you to do with your highlighter is we are going to highlight in one color, I don't care which color you use, the 10-point zone, which I do believe is this bullseye area right here. It's easy to see on my computer, but not so much on your black and white notes. So that's 10 points. So this one's not so bad, right? It's just 10 points. It's just a simple circle. And then on the other color, I guess I'll just use pink. That would be the 0-point zone. Do you see it? It's all of this extra section right here. So pick a different color. So that's 0 points. That way you can see it really well on your notes. Now, I'm going to highlight over here the same colors I use. So 0-point region would be this color right here. And then I highlighted this one in yellow. Okay, so the 10-point region is a circle. So what we're going to do is we're going to find the probability of the area of the 10-point region. Okay, that is going to be equal to the area of the circle specifically 10-point circle, and we're going to divide that by the total board area. Okay, so when you're doing your geometric probability, you want to have a plan. So probability is the space that you want to hit. So I want to hit that circle, okay? So I'm going to go ahead and I'm going to write the formula for that, which is going to be pi r squared. So that's the 10-point zone right there. I haven't plugged anything in yet, okay? But then I got to do the area of the total board. But what shape is the actual board? It's a square, okay? So I can just simply use the formula for a square. I can just do side squared, or if you want to, you can do length times width. I don't care. That's our plan. So now what I need to do is I need to figure out the radius of the 10-point circle. Does it tell you what the radius of the 10-point circle is? It does. It says 3 inches, right? So each little ring in the circle is 3 inches. So I'm going to put 3 in here. And you got to do a little bit of math to figure out the length of the board. So if you know that from here to here, so all of that is what? It's what? It's 9, right? So this little part is 3, this little part's 3, that little part's 3. So that means that is from here, from the middle of the board out to the edge is 9 inches. Now, is that the length of the side of your board though? What's the length of the side of the board? Yeah, it's 18 because you got to add both halves together. So the side length is equal to 18. Let's keep that in mind. So I'm just going to say 18 squared. So what I'm doing in the top is I'm finding the area of the 10-point circle, and then I'm going to divide that because it's probability, right? So I'm just going to divide that by the total area of the board. So I'm going to pause the video, type that in your calculator, and let's see what you get. All right, so to type this in on your calculator, we're going to hit like the little fraction bar, and we're going to go pi times 3 squared over 18 squared. And what happens is it gives you like pi over 36, okay? So if you want to change that to a decimal, so we're going to hit this little like opposite arrow thing right here, and then that's what you should have on your board, okay? So that's going to be approximately 0.087. You don't really have to go much further than 3 or 4 decimal places. 3 decimal places is usually really good. Now, that's a decimal. We need to change it to percent. That way we can understand it a little bit more. So that is actually going to be 8.7%. So all you have to do is multiply it by 100, which is the same effect as moving your decimal 2 places to change it to a percent. So you got an 8% chance of hitting that 10-point zone. So it's not likely. Now this part is the difficult part, because what's happening is you're going to have to take this square. Now this is going to be absolutely awful, and maybe you can try to do the same thing. That's not too bad. What you have to do is you have to find all of this area right here. Do you see it? Okay, that's what you got to do. So you have to find a plan for that. So the probability of that shaded zone, that is going to be the area of the square minus the area of the big circle. Right? So it's almost like that big circle has been like cut out of that square, and then that gives you the area of the 0-point zone. Okay? So what we're going to do is we want the area of 0 points, and we're going to divide that by the total board area. Everything, so if you're doing probability, you got to divide it by the total. That's the way probability works. But I think in this particular section, to find just the area of that 0-point zone, you have to do a little bit of math. Let me move this over here. Okay, so the area of the square isn't that like 18 squared? Because it's just like length times width, and your square is 18. So what is the area of the big circle? That's going to be minus pi r, I'm going to leave that blank, squared. What's the radius of the big circle? I'm going to pause it. I want you to look at it. So what's the radius of the big circle? It's what? So it's going to be 9 inches because it's center out. So you can even draw that in here right there. That's 9. So I'm going to do 9 squared. So we're going to type that in our calculator. So we do 18 squared minus pi times 9 squared. And that's going to give me about 69.531. Round it to 3 places. And the total board area is 18 squared. So let's type in that, and we're going to divide it by 18 squared. And that's going to give me about, because I'm rounding it, 0.215. So I rounded to 3 decimal places, which is approximately 21.5%. 21.5%. So I think we have enough information now. So it's going to be about 8.7% to hit 10 points. And then you've got almost 22% to hit the 0 points. So which one is more likely to hit? The 0 point or the 10 point? We are more likely to hit the 0 point section. That's 21.5% compared to the 10-point section. which was 8.7%. Okay, so this bottom half, this is going to be the most challenging problem of the lesson. There is a typo that I need you to fix. So mark out this little 2. It should say 4. So the side length of the square is 4. So what we want to do, we want to find the probability that it's going to land in the yellow region. So if it's really hard for you to tell what that region is, go ahead and color that part yellow. Or you can mark out, if you don't have a yellow highlighter, just mark out that word and color it whatever highlighter color you want. So I'll give you a second to do that. Okay, so I kind of like drew lines through that part. We're trying to find the probability of hitting that area. So I'm going to write down a plan because we need a plan. So the probability of the yellow area, that's going to be equal to the area of yellow, which is going to be kind of fun in itself, trying to find that. And then we're going to divide that by the area of the board. That would be your total area. Now the area of the board, that part's pretty easy. So I'm going to go ahead and just say the area of the board, wouldn't that just be 4 times 4? Okay, so I'm going to do 4 squared. The area of the yellow part, on the other hand, that's the challenge. So let's talk about the area in yellow. How am I going to find the area in yellow? So the yellow starts out as a square. Do you see it? It's just like rotated. So what I'm going to do is I'm going to find the area of the yellow square, but the whole square isn't yellow, correct? There is a big red circle like right in the middle of it. So I don't want to count any of the red part. So if I don't want the area of the red circle, what do I need to do mathematically to get rid of it? Subtract it, absolutely. So I'm going to subtract the area of the circle. So it's very similar to what we just did, okay? But what makes this problem more difficult is that I don't know the radius of the circle. We're going to have to find it, okay? All right, so we've talked about it, and we've noticed that this little triangle here is a right triangle, and we can use the Pythagorean theorem with a right triangle. Now, I don't know what the measure of A and B is, but it does give me a clue. It's going to be 2, right? So if all the way across that square is 4, then halfway across is going to be 2. So I'm going to erase that. That's going to be 2, and then that's going to be 2. So I'm just going to go underneath here. I'm going to say A squared plus B squared equals C squared. And I'm going to replace A and B with 2. So 2 squared equals C squared. 2 squared is 4. And 4 plus 4 is 8. And it's a hypotenuse, so it's a length. So I know it's going to be positive, so I don't have to worry about positive or negative. So I'm just going to, and I know it's going to bother you, but I'm going to leave it the square root of 8. I'm not going to worry about a decimal, okay? So I'm going to go back up here, and I'm going to replace that question mark with the square root of 8. So guess what? I know the length of the yellow square now. So the length of the yellow square, that's length times width. So I'm going to do, let's see, length times width minus the area of a circle. So I'm going to do square root of 8 times the square root of 8, which is just 8. Okay, and you can use your calculator to do that, but, 8 times 8 gives you 64. Square root of 64 is 8. Now, what is the radius of the circle? Do you see how the circle is half the length of the square? It's not going to be 4. I know you want to do 4. Now, it's not 8. It's the square root of 8. So all you got to do, listen, let your calculator do the work. So we're going to do the square root of 8 divided by 2. I don't know why I wrote 4. That's just half of the square root of 8. Okay, so I'm going to type this into my calculator. I'm going to pause the video, type it in. Let's see what we get. So this is what it looks like when you type it into your calculator correctly. So I'm going to round it to like 1.72. Okay, now I'm ready to go ahead and put this back up here, 1.72. Like I said, there's like so many different parts to this problem. So it's a big one. All right, so final answer for your probability, the area of the yellow part divided by the area of the total thing, so 1.72 divided by 4 squared is 0.1075. So that basically means that it's 10.75% of that board. So congratulations, you made it through that problem. Okay, so on the back of your notes, we're going to talk about experimental probability. And experimental is different than what we studied in the previous part in the lesson, okay? So theoretical is, what you should get in theory. So if you flip a coin 30 times, okay, if you flip a coin 30 times, you're approximately going to get heads and tails the same amount of times. But I'm going to tell you right now, if I have all of you take a coin and flip it 30 times, are y'all all going to get 15 heads and 15 tails? Absolutely not. Okay. So theoretical, what it does, I'm going to draw you a little picture here. Theoretical is like a line. So you're flipping a coin. Let's say you got heads this time, then you got tails. And then the more you do it, what it'll do is it will converge onto that 50% goal. So half of the time. So you guys know if you flip that coin 30 times, sometimes some of you are going to get maybe even 20 heads and then 10 tails. Some other people might get the opposite. But if you do it an infinite amount of times, you're eventually going to converge onto that theoretical probability. What this lesson talks about is experimental. So, for instance, you've got a spinner and you've got 4 colors on that spinner and you spin that spinner 20 times. Are you going to get each color exactly the same amount of times? Absolutely not. Is it possible you could do that? Yes, but it's just as rare as any other, possibility, okay? So what we're going to do with our experimental probability is we're going to figure out the probability using the experiment numbers, okay? So the red would be 5 out of 20 times. The green would be 9 out of 20. The blue would be 3 out of 20. And the yellow would be 3 out of 20. Now, the expected probability would be 1 out of 4 because you have 4 equal parts. So if you look at the question, it says which color is equal to its theoretical probability. So each one of them should have an equal chance of occurring, but only one of them actually was 1/4. Which color was it? Red, because 5 out of 20 simplifies to 1/4. Okay, so the answer is red. So if you actually perform an experiment, that theoretical is probably going to be different. You have to perform that experiment multiple times. Now, your book kind of puts this in as a side note, but that's called law of large numbers. So the more often that you actually perform that event, so you have lots and lots and lots and lots of trials, it's going to converge or it's going to get closer to your theoretical probability. Okay, does anybody have any questions? All right, just let me know if you have any questions at any point. All right, modeling in real life. We've got crustaceans, like lobsters and crabs and all that other good stuff. I digress. Okay, so it says a research team finds 368 out of 490 crustaceans have ingested plastic. Yeah, I guess that's a big thing with the oceans and the microplastics and stuff. The types of crustaceans, you got shrimp, crayfish, crab, lobster. You've got it on the table and it says that what's the probability that they chose a crayfish? Okay, here's the thing though, it actually tells you how many crayfish, or I'm sorry, not crayfish, but crustaceans are on this table. So let's put 368 total right here. That way you don't have to do it later. So what's the probability of crayfish? So how many crayfish did they pick, or did they find on this table here? 84. And then we're going to divide that by the total, which is 368. Okay, and you can either simplify the fraction on your calculator, which it simplifies to like 21 out of 92, but it would always make more sense if you just change it to a percent. So 0.228 or 22.8%. All right, this last one's for you. So this is a 4-day forecast. Today, it's got like a 10% chance of rain. Saturday, 80%. Sunday's 25%. And Monday is 85%. So it says order the events from least likely to most likely. So what you're going to have to do is you're going to have to find the probability of each event and then just order it according to letter. So I'm going to pause the video and y'all go ahead and do that. And then we'll figure out if you are correct. Okay, it rains on Sunday. That is 0.25. Okay, it does not rain on Saturday. That's 20%. Didn't we just found the complement, didn't we? That was from yesterday. That's the complement. It rains on Monday. That's 0.85. It does not rain on Friday. Today is Friday, apparently. So that would be the complement. So that would be 90%. So which one's the smallest? B. So that one's first. And then A, second. Third is C. And the last one is fourth, which is D. Okay, and just let me know if you have any questions, and we're done.